All right, welcome back, and this is the second video to help you get you started getting ready for our Hunter College Teacher Certification Program. Just a little reminder, these videos are not a complete class in Java. This is just getting you started. So you're going to want to go to the support materials that are on that website that sent you to here, to this playlist, and work through those. And I'll be talking about that a little bit here. But this is just to give you just a little flavor, a little example for each of the topics that we cover. And the last time we got Replit going, and today we're going to talk about data types, and we're also going to talk about some of those references. So I'm back at Replit, and I'm going to log in. And I'm going to log in with GitHub because I set up my GitHub account already. Now there's a difference here in that I've already made my REPL. So if I scroll down here, I'll see I got my Hunter CS Cert intro. I can just click or double click on this to go again, and it'll just bring me into that REPL. Or if I don't see it here, I can always click on my REPLs over here, and I'll see it here. And I just clicked on it, and it'll just take a second to boot up. And this is what we had before. And what I'm going to do is I'm going to make a new folder for today. Click on that. And I'll call it data types. That'll be that. And it's, there it is. And there's nothing in here. So I will create a new file, and I'll call this data types.java. And I'm using that with a capital D and a capital T. That's something known as camel case, which is common in Java. And anyway, so we can get started. So our program has to start with the word class, and the file name is data types. Notice this is in the data types directory, so it'll be data types. Open the brackets, close the brackets, and then we need our main. So it's going to be, now let's say I don't remember what this is because I haven't typed it 100 times. Not a problem. Just click over here. And you know what? You can even cut and paste this, but I wouldn't advise it because the typing will develop that muscle memory. Public static void main. So I'm going to come back to here, and it will be public static void main. And then it's going to be string, open close brackets, args, close the bracket. And then that goes there. And let's see, I'm just going to work in this one file. So I'm just going to close this down because we're not going to have to work in that. And then I'm just going to put in a quick system out print line, and it'll be data types, just so we know what we're doing here, semicolon. And let's just run and test this. So I'll come here and notice this is on console, but I don't want console. I want this to be in the shell because I'm working in the shell. I look at my directory with ls. Notice that I have my data types directory, so I'm going to cd into it. So cd data types, and I'll use tab to complete it. I can leave this slash or I can take it off, doesn't matter. There's my data types program. I can do Java C to compile it. And then Java, and I just used tab to complete it on the when I typed, but I just had that it completed the dot. I don't want that there, so boom, it works. Everything is good. Now you'll notice that I brought up the Scratch window here, and you'd be like, why do I have Scratch here? Because I know some of you have worked on Scratch, and I just wanted to talk about a little comparison, and I'll sometimes do this. With Scratch, you're brought into this environment where you can just start dragging things over, and make your program. And to be honest, I get Scratch for the earlier grades, but I just don't like working with it. I find it tedious and cumbersome to do all this drag and drop. I also have no idea how to get started, so I do because I've been using it, I've gone through tutorials and all that, but it's not as intuitive as they have you think, what do I do here? What do I start dragging? But this is kind of your main. It automatically gives this to you. That's what this is kind of like. And when you run your program, usually in Scratch, you run it by clicking on this, and you have to know that that's an event. And so it's when this is clicked. And then let's see. I don't even know what I'm doing. So sound, events, control, sensing. There's somewhere in here. Let's just start up here and take a look. There's something in here for say. Oh, here we go. Look, say hello for 2 seconds, and that'll have the cat say hello. And so this box here. This is main. And when your program runs, when you click this to run it, it runs this. So if I have other stuff, like if I have like, click on this, and it's like, I'm just floating, you know, and I click on this, nothing happens. Now, of course, if you just put something floating in Java, this is going to give us an error because you're just not allowed to do it, and Scratch ignores it. But if I put something in here, I'll drag that up to here, and it'll say hello. Basically, Java or Scratch is just going to start here and do the next line. And Java is going to do the same thing. It's going to start at the top and then do the next line. Start at the first line of main. So if we have like, we want to do this, let's say I'll cut and paste this. Whoops. Copy, paste it a few times. And if I compile and run my program, it does the first, the second, the third, the fourth, and we can actually, you know, make sure that we know this is the case. We can number these, and it's automatically saving it every time we type stuff. That's why I don't have to explicitly save it. 1, 2, 3, 4. Just like if I, one and then the second one. When I click on this run, it does the hello. Then it does, I'm just floating. It just follows top to bottom. So it's basically the same deal. It's just, in Scratch, it starts at this guy here, and in Java, it starts at main and boom, 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 boom. So let's talk about data. So for data, we're basically using variables. And in Scratch, you might know variables from here. And notice that you can't, like if I click on here, let's see if I can delete this variable. I have no variables. I can't just use a variable. I've got nothing here. I've got to create a variable before I can use it. So I've got to make a variable called maybe integer number, or just we'll call it an integer because it'll hold an integer. And then I can drag this to say, now I will set my integer to 20, or 0, 2, 0. It's similar in Java. If I want to create a variable, if I want to use a variable, I have to create it. And the way I do that is I put this up here in main, and the variable is created when it gets to that line. And if I want to create an integer, I say int, and then I give it a name. And that has created an integer. So I'm just going to clean this up before I continue with this demo. And I can now use it. Now, let's see what happens if I do this. If I print out number in quotes, it's just going to print out the word number in quotes. Let's actually compile and run that. So if I want to get the value of the variable, I can use the name of the variable, but without quotes. With quotes, it's a string. And let's see what this does. Let's see if it likes this or not. Now it says, hey, wait a minute. The variable may not have been initialized. We haven't set it up yet, and Java is sensitive to that. So in Java, we have to use the assignment statement. So maybe we'll say number equals 20. And notice how every line ends, I don't know what that happened there, with a semicolon. So, and if I leave those out, it'll give me a little error. But let's run this now. And let's run it. And now notice it prints out our 20. And it's similar here that if we, let's just break this out. Let's just say, let's move this set up to here. And we change this to, instead of printing this, let's see if I can do this. Let's go to our variable. I think in Scratch what we do, and this is why I find it, we can drag this over to here, and now when we run it, we first set it to 20, and then it prints out the 20. So it's a similar deal. You create the variable, then you can use it. Now, what happens in Java, whenever, and this will happen in Scratch in its own way, but when you create a variable in Java, it's got to go somewhere. So the way this basically works is when you run your program it starts with main, and it gets a blob of memory for main. And when you're in the summer with us, you'll learn all about this. This is just kind of the basics. And then when it gets to this line here where it says int number, it says, let me make a little box that can hold number. And then when it gets to this line here, it says, let me shove a 20 into here. And then whenever I see the word number, like here, it'll grab that 20. Not anytime when it's on the right-hand side or when it's in an expression like this. And then when main exits, this all goes away. So let me put a couple other things in. Let's say we have value. And another way we can set things up is we can actually put an assignment right in there. And it's giving me this little marker here. I'm not sure what this is. I think it's because we haven't used value at this point. But we could say here, let's make another variable called sum. And then we'll say sum equals number plus value. And not that interesting. Let's see what this is saying. Java in cannot be resolved to a type. Okay, a little weirdness going on. I think that should be okay. So int number, int value, int sum, semicolon. Well, actually, let's leave out the semicolon and see what happens when we compile it. Okay, missing that semicolon. Read the error messages. Boom. So let's do this. It compiles. And we run it, and we notice we're not printing anything out yet, so we don't know what's going on, but we could do something like, we could say system out println. If we want to get these all together, we can use a string context, and this will be covered in some materials that I'll point you to in a minute. So for example, we could say the sum of, and this is a string, and we can add it to something else. So the sum of number plus, and notice that's a second string with quotes, plus, and then the actual value equals, let's see if I'm right, open, close, number, open, close, value, open, close, and that's going to be sum, and that should do it. And I know it's a little messy to read, but I apologize. And then if we run it, the sum of 20 plus 30 is 50. I probably should have put a space after this. I will just add that in. And that'll look a little bit better if we run it again. And there you have it. And let's go through this with the diagram. So we start, main gets created, and none of this exists yet. And I'll just cross it out here. And so when we get to line 3, it makes a little bit of memory for number. When it gets to line 4, it makes a little bit of memory for value and puts a 30 in that. And then it makes a little box on line 5 for sum. And then when it gets to line 7, when it says number equals 20, it takes the 20 and shoves it into that box, into that little memory location. And line 10, it says sum equals number, so it looks up number. So this was sum equals, well, I'll annotate it up here. So I'll put a little comment. It looks up number, which is 20. It says, well, what's value? Value is 30. It does 20 plus 30, which is 50, and then throws it into sum. And that's how we get the 50. And that's all it is. And then when main exits, it goes away. And it's all mechanical. So you'll even see things like this. If we say sum equals sum minus 1, and then let's system out. Well, actually, let's not do sum. Let's do number equals number minus 1. And then let's just print these all out. So if we say system out print line number plus number, print line value plus value. I'm just going to print these values out. System out print line sum. So let's trace through this to see what we think it's going to do, and then let's see if it works. And this is also another good strategy, just to learn about this. So we come in here, this is all the same. So we get number, it just creates the box. Value, it creates the box, but it assigns the 30 in there. Number gets 20, puts the 20 in that box. Sum equals number plus value, 20 plus 30, puts the 50 in this box. Print, 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 but then when it says number equals number minus 1, so here, number, it looks up number and it says, well, number is 20. 20 minus 1 is 19, so it replaces this with a 19. That becomes a 19 in that box. And so when it prints out, for number it should print out 19, but value hasn't changed. That should still be 30. And sum hasn't changed because we didn't recalculate sum. It's all one step at a time, and that should print out still the same 50. So let's see how that all works. And there we have it, and it works just as expected. Now, this is just the beginning of overview of this, and what I really recommend you do in general is you go to Think Java, and Think Java is one of the texts, one of the references that I put in our recommended website. In fact, if we go to that site, and we see here it says getting started on your own. It has the, and I'll update this once this video is updated with the, so it'll look a little bit differently. But it'll have this link here, Think Java. You know, and that's this, I'll click it again. That's this interactive textbook. And really, all you have to do, what I recommend you do, is start going through it. So look over the preface, the way to program. I mean, that stuff, you know, might be kind of old hat to you because you have done programming and stuff in other environments. But this is variables and operators. So I'm going to open this in a new tab. And, you know, so you'll see here declaring variables. Now, they're talking about strings, so you'll want to read about that. You know, you want to read through this and work through this. But index, but it goes through much more example, you know, more examples. So strings, numbers, whatever. It talks about, well, we showed printing. It shows the mathematical operations you can do. It talks about floating point numbers, you know, like 3.149 pi. So work your way through this chapter to learn it and write the programs, type things in, experiment with this, and then at the end of the chapter there are exercises. So you can work through some of these to make sure you're okay with it, and then go on to chapter 3, and then chapter 4, and then, you know, just start working your way through. And the workshops will cover some of this, but you really have to put in the time and write the programs. And we've got, you know, we got an entire semester before our summer program starts, but so you have time to do this. But the best time to start now. Just say, like, you know, these days of the week I'm going to put in 40 minutes to this Java programming, and again, we'll get you all these support materials and a way to discuss things, you know, via email or chat or something. But that's it, and just start working your way through. So hopefully this video gave you a good starting point for this. Once we're done with that, we can see here, it's just under this data types, whatever. I'll see if I can make this public so you can view it but not edit it, because I don't want people to accidentally change things. So we'll see about that as well. But that's it for today. So get started on all of this. I know we're all busy, teachers with grading and all that and whatever. But this is going to get you ready, and this is going to really ultimately lead you into our program. And this is going to really strengthen you as a computer science teacher and as a teacher in general. And yeah, that's it. So I will speak to you all soon.